Yes. So now we're switching to English because we have a very nice keynote today. Guinness Acar. Did I pronounce it right? Oh, almost. Almost. Acar. Okay. We'll talk about from cookies to keyloggers. I'm sure none of you are bothered by this because we all use very nice anti-tracking software that will prevent us from being harmed by all this nonsense. Did you accept the policy that goes with the microphone?
I can't remember. Maybe I did.
So I'm sure he will introduce himself a lot better than I can. Give him a round of applause. Yeah.
Thank you. Thanks so much. So my name is Ganesh. I'm an assistant professor at Radboud University, and I do research on online tracking. So different type of ways you are being tracked, profiled, and targeted with advertisements online or on your mobile phones. And we'll also talk about some of the upcoming defenses of developments, what we can do about it. So it will be like a flyover, so different technologies for basically tracking you. Some of you may be familiar, such as cookies, but others may ever cookies or browser fingerprinting. Like, have you heard about browser fingerprinting? Can you raise hands? Oh, okay, more than half. That's very nice. But let's start with cookies, which is the traditional forms of tracking you online. And cookies are just like small text-based data, based with arbitrary content, websites or advertiser trackers can store anything they want, either through identifiers or some state, and this is basically done with either by server setting it or by some scripts. But this basically cookies let you recognize over websites. You can compare them to barcodes on supermarkets. So on your first visit, the website slaps a barcode to you. So this is your unique identifier. And on your subsequent visit to a website, and so you are being scanned, this is the same user. But it's not just the websites, what we call third parties or third-party domains or trackers, which may be present on many websites that you visit, like Google's and Facebook's, and now more and more common with TikTok. Have some resources on those websites, some scripts perhaps, that lets them collect or set a cookie with a unique identifier, so that lets this third party track you or recognize you across different websites. So this is basically a way to build a profile of you based on your visit, right? Cookies have, been the common way to track people online, but there are some limitations. Like, you can, as an end user, have some control over them, and this is basically a problem from the perspective of online trackers. So you can delete your cookies, you can reset your session, start a new profile. So the online tracking industry has been looking for some alternatives. And one alternative is what we call browser fingerprinting. So some of you already know that. So this is basically collecting a detailed information about your browser or your device, your laptop, and combining all these to obtain a potentially unique fingerprint. So this may include your screen dimensions, time zone, language settings, what operating systems you have, maybe the desktop manager you have. All this may have some effect that a web site or script can infer and obtain unique fingerprints. So very similar to the real human fingerprints. Of course, the problem from the user side is that we have no control over that, and we have very limited transparency. We really don't know when the website is fingerprinting us, let alone either a resetting or deleting it or changing it. So the initial study that showed that fingerprinting is a feasible tracking vector was by EFF. researcher called Peter Acar, whom we lost recently. So he showed through inviting participants to donate their fingerprints that when combine like a browser plugins, font, screen size, etc., some of the features, you can obtain a fingerprint that's like 94% unique. And this shows that even without storing any cookies, you may be tracked online. And since then, so this was 2010, since then there have been many different like variants or flavors or like a varieties of browser fingerprinting. And one interesting one is canvas fingerprinting. Have you heard of that? Canvas fingerprinting? Okay, like 10 or so people. So this is a technique that instructs your browser to draw an image in the background, so you don't see that image. But in the background, a script on a web page you visit invisibly makes your browser draw an image containing some text, and depending on your operating system, browser, graphics card, even the fonts you have, font library you have, what kind of font kerning settings, subpixel aliasing, smoothing settings you have, all these may affect the eventual image. So here, for example, researchers gift the images drawn with like Linux versus Windows versus different Windows versions. So for example, in one of our research, we crawled a large number of websites to detect when websites use this technique, and we found that over like 5% of them are using this. And the images you see on the right are the exact image drawn by the browser by these fingerprinting scripts. Can you guess like why this one sentence at the top? What's special about it? And like no wrong answers. Can you guess what's special about it, please? Excellent. This is a text apparently in Welsh language, and it contains the English, all the letters in the English alphabet, and only contains them once. So we call them pangram, and it's a perfect pangram, because it contains each letter only once. So why they may be using each letter to fingerprint? Can you guess the reason? Yeah, like diversity. So maybe your and my computer renders the letter C differently because of a font you have, maybe because of font setting we have. So they want to like maximize diversity by printing all the different letters. In fact, like later, more recent versions of that also try like emojis and like some Unicode letters. But the idea is that try to force your browser to draw an image that may be different from one computer to the other. And again, this may not be unique. Maybe we have like exactly identical computers and somehow we have the same canvas fingerprint, but you can combine this with all the other features like, again, language, time zone, which operating system, which version, and you may obtain a unique fingerprint. Some other APIs, so these are like the JavaScript APIs, meaning websites or scripts on websites may use these APIs to do stuff. So one of like more recently added APIs is called Audio Context API. So this lets web scripts to generate some signals and then apply some digital processing. And basically, so some of my colleagues found that a website used that API to build a audio fingerprint based on frequency response of your computer. It will likely be based on your audio hardware by generating a signal and applying some transformation like FFT. So again, just like have the computer do some stuff and then wish that this will be different from one computer to the other based on hardware, based on software, based on configuration. We can actually do a test. So this is a website set up by some French researchers, and it lets me view my fingerprint, and it also lets me view what makes me unique. Again, so uniqueness here is a problem because I can, by just my fingerprint can be identified, distinguished from other users. So let's see now. I had some browser window open here because, okay, so miunique.org and no internet. That's good. That should be very easy to fix. Let's see. Yes, here we go. So should we accept or reject? I don't care. Okay, see my fingerprints. See how identifiable you are. So now it's collecting. You can also do that yourself later, miunique.org. Okay, so the results are in. It says, yes, you are unique among almost 3 million fingerprints in our dataset. So let's see now what makes me unique. First, it says, well, you are using a Linux-based computer. Well, this is only representing like 22% of users. You see that it's like overrepresentation of Linux users. So they are more interested in seeing how unique they are. In a real data set, I can say, I guess, we probably stand that more. I guess the Linux desktop usage is, what is it, like 2 or 4%, something like that? Probably below 5%, right? Okay, so I'm using Chrome just for the demonstration purposes, not normally, but this is like 44% of the users have that. English, very present. But say if you have a more rare language, maybe like a Dutch or even like a less common language, that may also make you stand out. Time zone, well, just 13%. But this is just a very major property. So here you have a long list of properties. And again, so green means more or less good. So like everyone, like 90% share this, whereas red ones are. So this is, for example, my user agent string, which indicates what browser version I use and what rendering engine I use. So this is shared by only 3%. 0.3%, it's like 3 in 10,000 of that. And let's see. So let's skip that because, for example, canvas. So you see, remember the image we saw earlier? So this search will also use that, then emoji. And here is like 000. That means less than 1 in 10,000 have this matching canvas fingerprint. Fonts. So normally, like a website or scripts on websites, JavaScript cannot get a list of fonts from your computer. So it's not allowed. Okay. But there are some ways to do it using some sort of side channels. A script may draw an image, a text with a certain font, and then measure its dimensions. And if you have this font, there's a specific dimension. If you don't have this font, a default, like fallback font will be used, so they can actually detect that. And using that, they see here, like identified almost 100 fonts from my computer. And like, especially Linux users who install some MS fonts, I don't know if you do that, but so that also makes you stand out. And okay, so it's a long list. I'm not going to go all of them, but like you can see, hey, how many cores you have, device memory. So this has been a bit contentious. So like this shows 8. Actually stands for 8 gigabytes, but actually I have more. So this API to measure device memory was introduced, but then people said, like, why are we doing this? And then basically most browsers return a default value to hide the fingerprint. So some browsers do have some efforts to hide your fingerprint. So we'll talk about this a bit. But like screen dimensions, all that, so easy to measure. But not only screen dimensions. So you can, in JavaScript, measure the outer screen dimensions. I can also measure the inner dimensions. And subtracting that, you can measure the toolbar height. And you have some extra, I don't know, extension that is a toolbar, or for some reason your desktop environment renders toolbar a bit higher. This can also be fingerprinted. So many here, but also like graphics cards. So many graphic card features are exposed to the websites. So you may say, like, why? Why are they exposing so much information to the websites? So there's a conflict between this privacy, but also the other side is like more, hey, look, we have to measure what, I don't know, codecs you support to deliver you to right content. To deliver the content that your browser may run, or may run in the most optimized way. So there's always this conflict if you follow the discussions when these new API standards introduced. There is sometimes, not always, but there's a clash between, hey, like, do we really need this? Do we really need to expose this to the websites? I mean, websites, maybe you trust the website you go, but like what scripts they may have on, like what third parties they have on, it's a chaos there. I mean, like, we basically run so much untrusted code on our computers. But yeah, so we'll come back to the others later. So fingerprinting is what we call like stateless way of tracking, meaning like they don't need to store anything. So alternatives such as ever cookies. So this is not really cookies, but like a sort of like a variant of that. Sometimes also called zombie cookies, because they are hard to get rid of, hard to kill. So the way ever cookies work is that, again, they assign you a unique identifier, and instead of just putting into your cookie, they put on different storage mechanisms in your browser. So what are they? So local storage, IndexedDB, File Systems API. There are like so many like sort of weird, exotic storage mechanisms in the browser. So you can basically store this identifier in like, I don't know, 10 different places. So if the user clears their cookies, you can still refresh, or restore the identifier of this user from these other places that they failed to delete. Even cache mechanisms can be used to basically store a unique identifier. So let me briefly tell you how this works. So this is a bit because different than just storing an identifier. So, all browsers have this a cache feature, great for reducing bandwidth usage. If I go to a website with a, let's say, background image that is very heavy, like several megabytes, I don't need to download it again and again in my subsequent visits. So what happens is that, so on the first visit, browser stores this big image and a version number attached to that, which we call E tag. And on the second or third visit, browser says to the server, hey, I have the version 123 of this background image. Is it updated or is it the same? Server says, oh, you have the latest version. You don't need to download it again. Great, bandwidth preserved and latency reduced, great. But then here in this version number, trackers can actually embed a unique identifier assigned to you. And by just asking the server about the cached version or uncached version, they can just see who you are. And there's a demo for that. Let me see here if we can make this work. Okay, so here what we are going to look for is this number of visits. So it says 1, so I'm like a fresh user. So if I reload it, it will go to 2. So meaning this website identified that I'm the returning visitor. So everything so far normal, because they may have a cookie, and based on that, they might identify I'm the same user. So let's refresh again, 3. So now I'm going to, let's say, delete the cookies I have, see whether I can reset this counter to 0 or not. So on Chrome, so you can just click that and say, delete this saved data. Good, done. It says, hey, refresh. 4. So I couldn't get rid of it. I couldn't. So what would I do? What would I do? So maybe I go to site settings. So there is some other thing here, delete data. Yeah, I use that. I come back, refresh, 5. So what would I do? So like, is there like an end user? Probably that there where you get in, right? So okay, you resign. You say, okay, like I'm not going to. But if you're more, like really want to get rid of that, you have to maybe go to application and here all the different storage mechanisms offered by this browser, local storage, cookies, cache storage, all the nothing in here. So not even this like ID stored in the cache is not even exposed here. Well, what you should do is you should know the keyboard shortcut Ctrl-Shift-Delete, and that's like you delete everything, and then hopefully, yes, but like who would do that? So that's trick, right? So like that's storing this ID in like a sort of obscure places a user cannot delete or hard delete and track them. So not only on the website, so some research made by colleagues show that emails that we receive every day have these trackers embedded in them. So these are just like some images embedded in the HTML body of the emails. And when you open it, depending on your email client, so this pixel will be retrieved from a server. And then basically this is telling the server that you opened the email. So people report receiving phone calls from marketers saying, hey, I saw that you opened our email, so do you want to discuss, I don't know, products? So now, again, depending on your email client, whether you are using webmail or not, so this has like a different implications. Who here, for example, use email in plain text mode? Okay, so it's almost half. And I think that's like the best thing you can do against that. But there are also some protections offered by different providers. Like instead of you downloading the image, they would, for example, Gmail and Apple Mail, they download the image for you and serve it from their servers so that your IP address is not exposed to the sender. So that's one thing they do. But if they do that when you open the email, you are still exposing the fact that you opened the email. So one thing I think Apple does in addition is that they download the image regardless of whether you open the email or not. So I think that's the best out there, meaning the server observes and download of this pixel, but they don't know if I really opened it or my just email provider sort of opened it for me. But this is apparently very, very common right now. So this was about basically tracking you in the sense of like recognizing you in your different visits on different websites. But what data you share with different websites is collected. And particularly, I'm thinking like forms. So cookies, fingerprinting, every cookies, okay, you are being identified, but what data you share with different websites are collected, let's say. For example, passwords, credit card numbers, names, addresses, phone numbers, all these personal info you enter into online forms. So they can be easily read by a script present on this website. For example, this specific website. So on the top right, you see my ad blocker showing there is 37 tracking related requests made at this stage. So question is, so if we think about all these like different advertising analytics scripts present on different websites, do they also like collect this data you enter into the forms? And maybe you can guess the answer. So one a particular type of scripts I want to talk about here is that session replay scripts. Have you heard about that? Session replay or session recording scripts? Yeah? Have you used it on your website? No? That's a smart decision, maybe. So session replay scripts are sort of advanced form of what we call analytics. So they collect, so they are embedded on the website you visit, and they collect all the interactions you make with the website, including like mouse clicks, key presses, scroll up and down, and like data you enter into forms, along with the full source of the web page and all the modifications made after that. And so like the marketing material, if you read them, they say, so this is basically as if looking over your visitor's shoulder. So they collect all the data, and on the server side, they bring it together so that it's like basically screen recording of you visiting the website. Really like impressive in terms of the tech, but at the same time, it's like having someone looking over your shoulder, really. And unfortunately, since these session recordings require collecting like all the page source and text, like whatever you see on the page may also end up in these recordings, like meaning sent to the third party, and whatever you enter into the forms may also be captured and sent into to these third parties. And in study we did, we found passwords, credit card details, like student grades, health data, purchase details, including credit card, are sent to different third parties. Some of these, incidentally, like this example. So this is a login form of a Popular Ads, is an advertising company, but irrelevant here. So they have a login form from their customers. You go there, enter your username, your password. As soon as you click this eye icon here, your password is sent, and it's sent key by key, as you see in the payload here, like 1, 2, 3, 4, 5, 6. So this is what, why people compare this sort of scripts to keyloggers. I think it's not exaggeration. So can you guess what went wrong here? So why did it started leaking when we click this eye icon? Any guess? Please. Screen scraping? Yeah, a bit. Please. Excellent. Excellent. So the reason is these session replay scripts sort of know that it's a very risky business what they are doing, like scraping all this data from forms where you can enter your password. So they have filters for excluding passwords. They say, hey, input type is password, do not collect that. Because they will be liable for that. And they're actually being sued in some countries right now. But when you click this eye icon, so the website basically replaces this password field with just a plain vanilla text field. And then the script says, oh, this is just an input field. Why would I just collect it? And there, things go wrong. So basically, they have some rules for filtering out sensitive data, but these rules are so fragile. It's easy to basically that they will be bypassed. Here's another example where credit card details are leaked. And again, so there are some rules for filtering out credit card fields, but people use so many different names, IDs, formatting, markup. So it's very hard for them to capture all the cases and exclude all the sensitive data. And here I think even the CVV number, which is supposed to be even more secure, being sent. So this was all, what you type somehow being collected, sometimes intentionally, sometimes unintentionally. This example is, I think, for me, maybe one of the most extreme examples I found in my research. So in this case, trackers what they do is they abuse the built-in login manager feature of browsers. So when you go sign up for an account on a website, so the browser asks you, hey, do you want me to remember these credentials? And this is very good in terms of security because this may prevent password reuse across websites. So this is a big problem, right? So you use the same password on 10 websites, one of them gets hacked, and then password is leaked, then they can take this password and hack into your other accounts on 9 other websites. Credential stuffing attacks. So this built-in feature, password managers are great. If you use them, a third party can also abuse that. Again, so this only works on like a website that you store this password at, and then you visit this website again. So it needs to be the same website. There is a limitation. But so let's say I open the account, and then I visit the website again. This time, this tracker script, what they do is they inject an invisible login form, and your browser basically does not check if this form is visible or not, like whether you intend to fill it or not. You may think like, why? I see some confusing faces. So from the browser's angle, it's very hard to detect whether something is visible or not. It may sound a bit weird, but unfortunately. So then this like invisible login form injected by the script, browser happily autofills it with your password and username, maybe your email. And then the Spreker script just collects your email, hash it, and send it to use it as a identifier. Because your email is the same between desktop and mobile. Maybe the same email you can use in like an offline realm, maybe like a signing up for a, I don't know, like a discount card at a supermarket. So with this, just this email address, and sometimes it's hash, so they can just link your visit across different websites. But basically, injecting an invisible login form to ask your browser fill it. So there's also a demo of that, but maybe for now, I'll skip that. So in one recent research, we did a large-scale study of, like, if I go to a website and fill in my email and password, but not click submit. So I just type my credentials, and then I will stop there, because we know from research that many people basically start filling out forms and they decide not to submit it for different reasons. And will these emails and password be collected? So we looked at this problem. And so if you're curious about what kind of research is going into this, to research like that, so most of the time it involves some crawler. Has anyone developed a crawler here before? Yeah? So for what purpose, if I ask? Uh-huh. Yeah, very cool. And yours, sir? Oh, pretty cool, still. So yeah, like the crawlers you have to use today are basically needs to be, so they cannot be something like curl or wget. You need to like visit a website with a JavaScript enabled user agent, a browser, and then simulate what a user does, for example, accepting or rejecting cookies. And then in this specific study, we were again simulating a user filling out forms. So you have to identify the form elements and fill them in. Just identifying this like a form elements, for example, we needed to build some small, really lightweight machine learning models, because rule-based methods, they don't work. It's like web is like chaos if you work at scale. There are so many different designs and markup, etc. Anyway, so we visited 100,000 websites using this automated browser based on this software by DuckDuckGo, tracker radar collector, but so basically it's an automated browser. And 100,000 websites from 3 different locations, like US, So 2 different locations, US and the EU. And the results are, so we found that your emails are sent to a third party on like 2,600 times in the EU versus like almost 3,800 times in the US. And again, this is just before submitting. So you just type in your email and it's bam, went to a third party. And if you just look into the tracking related domains, we found like 1,800 or so in the EU, whereas almost 3,000 in the US. On this, again, these are same websites visited from 2 different locations, and we see like very different results. So this may be because of a regulation or other things. So we cannot really attribute it to something specific, but there's a big difference at least. If you look at like websites where your email is collected and how it is collected, so it may be just like they collect the email as is in, let's say, plain text. In some cases, they hash it. Again, hashed emails, they may not use it to send you emails, but they may use it to track you. Emails are great for, again, tracking you across different domains, different like platform, mobile and desktop. So we see like different forms. But very high-ranking websites, like very popular websites, like a lot of newspaper websites, health-related websites you see, especially in the US crawl. Again, just typing in your email is enough. When you look into the categories of websites, something interesting. So we see that like shopping-related websites have a lot of trackers, probably for remarketing. So if you start shopping but don't finish purchasing, and so they may want to get back to you. Whereas like government, military websites, but also like adult websites have like 0 of these trackers. That's interesting. So maybe you can attribute maybe they think this will freak out their visitors, so they don't use a lot of repeat tracking technologies. I'm not sure, but we really like double-checked our data to make sure this is really 0, like really 0. Like not visiting them, we did not. It's all automated, all automated. Yes. That's interesting. But like, again, so this is, for example, one of the emails we received. Again, we go to website, find some forms with login or maybe email. And for example, Diabetes UK website, reach out saying, hey, we noticed that you were on our online donation form, but did not complete it. So this is very open. So maybe this is like a nice virtue that they are very open about it. But at the same time, I haven't seen anyone thinking, oh, this is okay. Okay, this was emails, more about tracking and maybe marketing you. But we also found some password leaks on more than 50 websites. And almost all of them these passwords are sent to Yandex, the Russian search engine, like the Russian Google alternative. So Yandex has a product called Yandex Metrica. This is an alternative to Google Analytics. So for measuring your website visitors or how your websites perform. And this Yandex Metrica has a session replay feature, like one I showed. And only on 50 websites, they were collecting passwords. So looking into this website, because this Yandex Metrica is present on tens of thousands of websites. So we found probably this is some weird interactions with the underlying web framework used. And so we reported to them and they fixed it in a reasonable time. And 2 other providers of, again, Mixpanel is a session relay company, and LogRocket, they were also incidentally collecting passwords on some websites. Again, this is like a side effect of basically scooping up so much information that really passwords or other sensitive data ends up there. So if you want to summarize until this point, so we have different tracking mechanisms like cookies and error cookies. That's hard to get rid of. We have fingerprinting, doesn't require any ID stored. And then we have like email-based tracking, etc. And we found that these scripts sometimes lead to exfiltration or wasted collection of your data, such as password, email, or credit card numbers. But this was more about basically desktop browsing, whereas more and more will be, so I'm going to skip this part for sake of fun. We are more and more using mobile devices, like smartphones. Anyone got a smartphone? No? Okay, I thought this may be the crowd too. Okay. So this picture of Pentagon, so this is from a New York Times article where the reporters went ahead and bought a data set of location pings, location data set, and they visualized the data, mapping it to the exact coordinates in the world, and they found these basically location pings from places like Pentagon, places like White House, and I'm guessing like if we do for the Dutch Parliament, we'll see like similar results. So what's happened there? So on the mobile apps or smartphones, so we have like a different tracking regime, let's say. So we don't have cookies, although we might, but they work differently. Instead, we have this like a third-party SDKs provided by Facebook, by Google, TikTok, that app developers integrate in their apps, and then you have tracking in-app and across multiple apps. But most of the time, the identifiers used to track you are platform-specific, like IDFA or AdID. So what we know, for example, that when Apple released this update called App Tracking Transparency, where they ask you, this app wants to track you, yes or no. So just giving users this option reduced Facebook's revenue by $10 billion. Just a very simple dialogue. So you can see how important this is. Again, so instead of a third-party scripts, we have third-party libraries or SDKs, but in mobile we have access to much more novel, more precise or sensitive data, like precise location, sensors, and you know we always have this like smartphone in our pockets, so revealing our activities or our locations. So the IDs look like this, nothing special, but they are mostly using this UUID format, like unique to person. You can go ahead and reset it, but again, who does that? If you deny tracking in iOS, on this like a dialog asking, hey, this app wants to track you. If you say no, a 000, like a zeroed out ID will be given to the app. So Android apparently has a similar feature in the settings somewhere. So like apps, again, ID-based tracking is something, but there are reports of applications collecting like very detailed data that may amount to fingerprinting. Again, this is like a third-party SDK, like advertising, embedded in a game called Run Rich 3D, doesn't matter. So they collect your settings, volume level, brightness level, battery level, what language you have, dark mode or not, enabled keyboards, calendar type, all these are different things. Again, may be combined to obtain a fingerprint if you, again, give a spoofed identifier. So platforms, there are like two major platforms, like Apple and like iOS and Android. So Apple has a specific policy against fingerprinting, and they are very hard about it. If you watched this TV show called Super Pumped, the Battle for Uber. Has anyone watched it? I would expect, no, I don't think it's shown here. So this basically tells the story about the Uber's early days. If you know, it was a very toxic management, and but what's relevant here is that they tried to introduce some fingerprinting in the Uber mobile app, but again, they knew that this was against Apple's platform policies. So what they did was they used geofencing. So if you are using the Uber app from Apple headquarters in Cupertino, you will get a different version of the app. If you're using it outside, you are getting the fingerprinting code. But some Apple engineers realized that, and this resulted in the Uber CEO being called to the Apple headquarters for a big scolding, apparently. And it's told in this book, this TV show is also based off. So it's not just drama. But yeah, so this is like a very interesting case. But you know, when you read materials about this online tracking or mobile from say, advertising companies, etc., they will say, look, so this data, okay, we collect that, okay, so there is no dispute to that, but this is just attached to some identifiers, not your real name. So what's the big deal? They'll say. Well, I mean, if you have access to such precise locations, it's very easy to single out individuals, and it's not hypothetical. So in the US, some religious zealots went ahead and bought some of these location data sets, and they were looking for priests who may be involved in dating, gay people. So what they were looking is very easy. So at night, who is sleeping at the, let's say, where priests live, or maybe around the churches, or they know the location of where priests live, and then where do these people go? And they found that, for example, some of these identifiers both live in the houses dedicated to priests, but also they go to gay bars. So it's so easy to basically reveal that. So you just match the identifiers, but you know who lives in this specific location. So they singled out individuals and now apparently investing more money in that. So the app used in the previous case was actually from Grindr, so it's a gay dating app. And Grindr is fined in the EU for collecting or processing data without consent. And some of the data they collect was investigated by some researchers. So it's not just the app, but the third parties embedded in the app. So not only the precise GPS location or gender, but also your HIV status, when you are tested, age, height, etc. I mean, so apparently there may be legitimate reasons why sharing HIV status may be useful in a gay dating scene, but why send this to a third party? Okay, if this is really necessary, why are the app, the Grindr, sending this data, very sensitive data to, optimized localytics, some companies that who no one heard. And so this data is sent to these third parties, but then it doesn't end up there. So there are very great investigative journalism pieces investigating this, is the chain of selling this data and reselling it and reselling to many other parties. And then, these are packaged and basically bought to others, including for example, US military, while buying location data that some of this coming from, coming from Muslim prayer app, Muslim dating app. So this was, I think, a bit too far. Google actually kicked out this location data broker from their platform. But now this is still going on. There's a great viral story about how US intelligence agencies find out Well, actually, this data set is so rich that we can actually track Putin's movements, like Vladimir Putin. How? Very easy. Again. So, this person has a big entourage around him, and not everyone has a lot of operational security, tradition. So they would, these phones move with Putin, and then you just, track where they go. So if you have the data at the scale, it's so easy to, find whether you went to some demonstrations or protests, because they also have the time attached to it. And if you think, okay, where do they buy this data? So it must be inaccessible to most people. Well, no, there are an online website where you can go and buy data such as location, movement, food traffic data, but 100% privacy protecting. So maybe one positive thing, although it doesn't apply to all. So this is, for example, where this specific data set is available, where the data is coming from, all over the world, except most part of Europe. So maybe this is a sign of things are a bit better here, but I wouldn't be too complacent. So Google had a issue with location history where I was involved in basically proving it or demonstrating it. So in the Android platform, they had an option called location history. And the interface was saying, if you turn this location history off, your movements will not be recorded. But there was a separate thing called web app activity, and if you turn this on, actually Google was still collecting your data, your precise location. And this was, basically just misleading users. And they were sued, and they had to pay almost $500 million. And even some documents came out from the proceedings, and even Google's own engineers were saying, this is, not very clear. Okay, so there are, if you look at the mobile track data collection, there are really the permission system, but there's also ways to get around it. Instead of using your precise location, they may use the a GSM or 4G towers around you to geolocate the phone and use that. And if your photos have location information in them through this EXIF metadata, some apps were found to basically parse these photos and extract the locations from the photos and use that instead. So ways to get around it. And maybe a sensor data as well. On the web, even on the website, you don't really, the website don't need a permission for that. I don't know if you know, but so there is, let me see if I briefly show you the demo of this. So we did a study of, for example, which website accessing your sensor data, so what sensors, orientation, accelerometer, gyroscope. And if you start this, you will see that different readings from the sensors already available to the website. So I did not have to give permission at all. What about the battery? So who thinks here websites can, without any permission, read your battery level? Hey, good. So I think the talk achieved its objectives. Well, yes. So this is a website. Here you see 82%. Here I see, where is it? 82%. So easily available. Although this depends on the browser you use. On Chrome is available, whereas on Safari and Firefox, it's not available. So they made the decision, actually part motivated by our study, that, well, why are we exposing better level to websites. Like they basically disabled the API after we did some research showing how you can actually use that for tracking purposes. Okay, just to recap, so instead of cookies on the mobile, we have these identifiers provided by the platform, and precise locations, well, you can infer so much about them, really. We really didn't touch much about it. So in the remaining like 7 minutes, I'll maybe, I'll take questions. But also very quickly, I want to fly over some recent developments, because like really this online tracking embraces a problem, and some browsers are doing taking some steps to address it. Now many browsers come with built-in protections against online tracking, like Safari, Firefox, Brave, DuckDuckGo. Google has a separate project called Privacy Sandbox. And so, for example, one recent technology is to basically partitioning each cookie to each website, meaning a cookie or identifier set for you in one website will not be available in other. So this is called partitioning. And so this means this will look like this. So now like 2 separate cookies. So then you cannot be tracked by the cookie. Safari's ITP or intelligent tracking protection, so they say they use like a basically internal machine learning model to detect trackers, but also they time limit the cookies and delete them after a while. So more and more browsers interact with this cookie dialog, consent dialogues automatically for you if you want. So Google has this big project called Privacy Sandbox. It's a collection of like different proposals. And one of the main ideas is to, instead of profiling you by, I don't know, thousands of different companies, your profile will be kept locally. And then advertisers will be able to use that profile to show you ads, targeted ads. Without really like reading and getting your whole profile, they can say, hey, if the user is interested in tennis shoes, we have this, advertisement, and it's called Topics API, and like there is an actual interface where you can go and check your own profile. Okay, but none of these unfortunately prevents against more like security issues with advertisements, like malicious advertisements. So this is a search result for an OBS. This is like a video like editing and streaming app. So if you search for OBS, you get this ad, nice, you go download it, and now you have virus on your computer. Well done. Doesn't Google vet these ads? Well, not good enough. Here's another one, you try to download TeamViewer, and actually maybe you even like typo, and bam, you have a malicious software, advertisement for a malicious software. Now we know that this malvertising campaigns also lead to ransomware, hitting, among other, hospitals. This is from a research we did on advertisements shown on children's websites, where they can go and study math and music and algebra. Yeah, like, of course, yeah, why not meet singles there? And this is, for example, you may not know, but this is an advertisement from the largest sex toy shop of Germany. Okay, so what can we do? We can use ad blockers. I hope you're using them. This is also good for security to prevent this malicious advertisement reaching your computer. Install it on everyone, grandmas, grandpas, mother. Even NSA now suggests that we should use, or their personnel should use ad blockers. This is real, nothing. And on mobile, yeah, you may allow location access only when an app news or turn off your location. I think this is the most important thing there. And of course, don't mind the apps you install, because they have much more privileges than websites. If you want to not give your real address to online businesses, so there is some services such as Firefox email relay or DuckDuckGo email protection, and which basically gives some temporary addresses to the websites, and you still get your email, but don't close your permanent address. This was the last email, last slide. Oh yeah, okay. So that's the end of it. Thanks so much for your patience. Yeah. I guess we have a few minutes for a question, maybe.
I was wondering about the fingerprinting, because given it's mostly software, there are a few hardware-related things. How can it be used for tracking? For instance, if you have the battery level, if it says 82%, it doesn't say anything about me.
So why is a problem, are you asking?
How is it used?
How is it used? So again, so it is to identify you across different websites, not based on like a cookie, but rather just like on different websites you go, they obtain your fingerprint, and if this fingerprint is unique, then they know that you are the same visitor. So
it's not really stable, right? I mean, it can change at any time.
So yes, for example, you update your browser, the version number changes. So the good fingerprinters have measures to match this changing fingerprint. So this is one of the more challenging part of it. I didn't go in detail, but so like they can predict, for example, okay, Chrome 1, 2, 3, now it's 1, 2, 3, 4.
It's probably.
Battery level, for example, it fluctuates a lot. You must not use it as like a permanent identifier. So they need to have some fuzzy matching on the server side to expect this updates, yes.
Okay.
Yeah, that's, for example, one fingerprinting company CEO was saying that was the difficult part, like matching, changing fingerprints, yeah. But you have very good insight, yeah.
Have you looked into things like TLS fingerprinting already?
Ah, yeah, so very good.
That's a new hot item.
Yes, so TLS, to be honest, like today actually my student Jayate will be giving a presentation on fingerprinting TLS services. I think it's at 10:30 or 11, at 11, around that. So I have not. So it's a bit more challenging to do that instead of these scripts, etc. But so you can definitely use some of the details there as well. But most of the time what you can get there is operating system version and maybe some more, yeah. But it's a bit harder to basically expose this network level data to the server. It's possible theoretically, yes. There are great tools for that, GA3, POF, etc. Nmap even, yeah. But so yeah, I have not personally looked into it, yeah.
Last question.
Have you looked at the effectiveness of the Tor browser and the Tails distribution against fingerprinting?
Yes.
And
yeah, please.
Can we still trust a little bit of them, or is it also out the window?
That's the best. Tor browser has the best defense against browser fingerprinting as well. So Tor hides your IP address by routing your traffic through 3 hubs. But they also have, less known is, they also modify Firefox browser to make it less fingerprintable, such as they disable some APIs and some configuration or properties, they lie about them, but you have to lie in a smart way, so to make many people look like the same. So they have a lot of defenses, and they have some of the best defenses against browser fingerprinting. Yeah. For example, like they control even the fonts that the browser may use by shipping the fonts so that everyone uses the same font set. So if you look at like your Tor browser installation, you will see things like that. Yeah. So they're